To start the experiment, we're going to click on Thermodynamics in the Virtual Chem Lab and choose Hess's Law. You'll need to record the mass of the sodium hydroxide, and if you can't see it very well, you can just click in there to zoom in on that. And then we have water in the calorimeter that we're told is there. There's 200 milliliters of water, and my shaft is on. And if it's not on for whatever reason, you can see it spinning here, and the green light is on, but if it's off, you can just click on here to turn it on. So you want to start saving your data and get a baseline, and of course you can accelerate the reaction here. And we've started our baseline collection of data. Our temperature here is 25.01 degrees. And I can take this sodium hydroxide and it'll snap into place, and then we'll add it to the calorimeter, and it's going to continue recording your data. So you can turn the acceleration on again. And we're going to watch our temperature increase. And once it hits a maximum, you want to collect data for another 20 to 30 seconds. All right, then we can stop. You can open your lab notebook, click on calorimetry data, and you can see what your temperature was, and then you want to get your maximum temperature. So once your experiment's done, just click on this red bin over here to clean up the lab bench, and we'll go into the stock room. Click on the clipboard, and we're going to find heat of reaction HCl plus NaOH. Notice that there's two of them here. For part 2, you want to choose the one with sodium hydroxide as a solid. And we have sodium hydroxide here again on the balance, and you want to record that mass. And then we have a beaker here with 100 mils of 1.000 molar HCl on the lab bench. We want to save our temperature to get the baseline. And then I can add this now. It'll snap into place. And then your sodium hydroxide should be added. That will also snap into place. We'll add that. And we're going to collect temperature here. You can see that it's increasing rapidly. And now it's maxed out, and I'm collected in a little bit more, so we can stop now. Open my lab book. This is the second set of data. My temperature for the initial, and then you can see what the maximum temperature was. Right, so record that in your table, and then clean up the bench. We're going to go back into the stock room, and now we'll choose sodium hydroxide plus HCl, and this is going to be aqueous. So our sodium hydroxide now is a liquid. The beaker on the left is the HCl, so we want to make sure again to save your data. This is the HCl, we're going to add that, and then we can add the sodium hydroxide, and that will snap into place. We're going to do the same thing, watch the temperature change. Once it hits the maximum, we'll let it run for another 20 seconds, and then we can stop the data collection. Alright, that's good. Then we can hit stop. Open your lab notebook, look for your initial temperature, and then our maximum temperature, so record that into your notebook. For the first of your calculations, we have to calculate delta T, and that is just going to be a subtraction of the two values. So you have delta T equals T initial minus T final, and that's usually the absolute value. So we're just going to do that for each of them. So for reaction 1, I have 24.99 minus 30.07, and that's the absolute value. So even though this number comes out being negative, I'm taking the absolute value, so it will be positive. So this is 5.08. And then I'll do the same calculation for the other two reactions. And you should also notice here that my reaction that I ran, so it's going to be different from your data, but the calculations will be the same and your reaction is very similar. So my reaction here is with potassium hydroxide and not sodium hydroxide like yours. So your delta T is going to be the same calculation, and you can see how I've calculated here. And remember that when you calculate delta T, that's the change in temperature in Celsius. When you go to find the delta T in K, it's going to be the same value as it was in C. All right, next, so we've done the delta T calculation, and we have to calculate now the moles of, for me, is potassium hydroxide. You will calculate the moles of sodium hydroxide. So to get to the moles of KOH, we need to figure out the grams that we had. So I have 3.9972, so this is for R1, or reaction 1, 972 grams. And I need to divide it by the molecular weight of KOH. And so for me, that is going to be 56.08 grams. So 56.08 grams is the molecular mass of potassium hydroxide, and to get to the number of moles, I need to divide my grams that were in the reaction by the total molecular mass. And you will use the mass of sodium hydroxide, not potassium hydroxide. So I'll do this calculation, and that comes out to 0.07128 moles of KOH for reaction 1. And the reaction 2 calculation, it will be the same. And this comes out to 0.07152 moles of KOH. For reaction 3, we're going to do this a little bit differently because in reaction 3 we used 2 liquid solutions. So we're going to take into account the molarity of the solution. For R3, we used 100 milliliters of a 1.0000 moles per liter solution of KOH. So yours will be NaOH. And then we would have to just multiply it. However, our problem here is that 100 mils has to be in liters, so this will just be 0.1 liters. So this will be 0.1 moles. All right, so there's the calculations for number 10, and we can put those values into the table here. All right, so we go to our next slide. So next we need to calculate the mass of the mixture in each reaction. For reaction 1, we're going to take the mass of water plus the mass of KOH in solution. And the mass of water, we can assume the density is 1 gram per mil. So if the density is 1 gram per mil, we can multiply that times 1 gram per milliliter to get the mass, which will be 200.0 grams, plus the mass of KOH. So that's our mass for reaction 1, and then you can fill that out in your table. For reaction 2, we have 100 milliliters of water plus 100 milliliters of HCl, and again, that's going to be, the density is going to be 1 as well. So we have 200 grams again, plus 4.0111 grams. So if the density of water is 1 gram per mil, the density of HCl is 1 gram per mil as well. It's the same conversion here. And for reaction 3, we're adding the 2 solutions. They all have the same density of 1 gram per mil, so we have 200.0 grams, and there's no extra mass here, so this is the total mass, is 200.0 grams for that solution. For the next calculation, we have to calculate the total heat released, and that assumes that the specific heat is the same as pure water, which is 4.184 joules per Kelvin times grams, and then we'll put that in our table. And then remember, the heat of reaction when you're calculating it is the mass of the reaction times the specific heat times delta T, and delta T needs to be in Kelvin, which is fine because we already have our delta C change, or our delta T in Celsius, which is the same as K. So for each reaction, for reaction 1, I have the mass of the solution times the specific heat of water, and my delta T is 5.08 K. So I'll do that calculation. So this will be 4335.9 joules. So my units that cancel out are grams and Kelvin. I'm left with joules. So we'll do the same reaction for the other 2 as well. We'll do the same calculation for the other 2 reactions. So our values here are so that is our total heat release, so I can add that to my table. I'm just going to round here to the whole number. So those are all in joules. So to do our energy released in kilojoules per mole, for potassium hydroxide, we need to convert each of our joules of heat into kilojoules, and we'll do that by dividing by 1,000. So that's in joules. For every kilojoule, there are 1,000 joules. So you're going to set that up for each of them, and this ends up being 4.336. This is 8.570, 4.929 kilojoules. And then we're just going to divide by the number of moles, which was from our table that we calculated earlier. So we'll get 59.56 kilojoules per mole, 119.8 kilojoules per mole, and 49.29 kilojoules per mole. Then I can just fill that into my table. All right, here we're going to show the reactions for the equations 1 and 3, which have to add up to number 2 for potassium hydroxide. So for my first reaction, I had potassium hydroxide, which goes into potassium ions and OH minus ions, and the energy for that one was 59.56 kilojoules per mole. For reaction 2, I have K plus aqueous plus OH minus sorry, this is reaction 3. I had 49.29. And then if I do my cancellations here, K plus cancels, OH cancels. That one should be K plus. Then I am left with reaction 2, which is KOH solid plus H plus aqueous plus Cl minus. That's going to go to H2O. To add up to that. All right, and here we're going to see what the difference is in our calculations versus what we actually saw. So for the percent difference, we have the heat 2. This is absolute value. So our heat for number 2 was 119.8, and that was what mine was. And we're going to subtract 1 plus 3. So 59.56 plus 49.29, all divided by my 119.8 value, times 100. So my percent difference here was 9.14%. So for that data set, it was not very accurate.